In this video, we'll give an example of how array is used specifically in sorting. Sorting is a computer algorithm that looks at a collection of elements and determines their order in terms of their value, usually. So if you do sort a collection of elements in ascending order, you'll start with the lowest elements first, all the way to the highest, descending order, vice versa. So in this example, we're going to talk about selection sort and how array is used in this sorting mechanism. Take, for example, this array of 10 integers, starting with values of 10, 1, 3, all the way through 2. This is unsorted array. The goal of our sorting attempt is to sort all of these elements in ascending order, meaning the outcomes should be 1, 2, 3, right, so on and so forth. And the highest element in this case is 98, being the last element. So this would be a sorted array in its ascending order. And we're going to make use of what's called selection sort, which is not the most efficient sorting algorithms out there, but we're going to use this one to illustrate anyway. So the idea is that for each index position k in term, this is what we're going to do. You start with the very first element at index 0. And what we're going to do using selection sort is to compare this number against its adjacent one in the order. So this will be the first comparison, second comparisons, third comparisons, so on and so forth. And the very last one, assuming you have n number of elements, the very last comparison is n minus 1, assuming you have a total of n elements. Doing every single comparisons, we looked at the value of 10 against every single one of these. If let's say we have a value, let's say 98, exceeding the value of 10, that 98 stays as it is. However, if we come across a number that is smaller than the target or the base value of 10, then we do a swap because we want the smallest elements first. So there's going to be a swapping element every time we come across a smaller element than its target. So once we are done comparing 10 against all of its adjacent elements all the way to the end, we go to the next iteration. The next iteration involves looking at the partially sorted array of elements. So look at this element, target, comparing against its rest. So at the end of the very first iteration, this target 10 would have been swapped, replacing with the smallest one, which is 1 up there. So 1 would have been the rightful spot. So very next iteration involves looking at then the very next element against all of its adjacent elements. So this is what we called O of n times O of n minus 1, O of n squared. Now, the complexity analysis is beyond the scope of this illustration, but suffice to say that is the algorithms that we're going for in selection sort. There's a lot of literatures online that talks about selection sort algorithms in details. We will not be discussing those details in terms because we want to illustrate how array is used in this application. So let's move on to the next page. The algorithms that we just talked about is illustrated here. And this is basically done in 3 phases. We start up with the selection sort, which takes in an array of integer and its length. We use this length information to iterate through every single element, comparing them against each other, and do a swap if warranted. So a swap takes the target element starting at count equals 0 and the second batch of integers in the remaining array. And we do a comparison. This is number 1, this is number 2, and notice that swap is nested inside this for loop. And what this swap is doing is just comparing against the first and the second value by reference. And note that reference simply passed by address. So when we do a swap, these informations are swapped inside the array, and they are not copies of the original argument. They're simply the original arguments with a different name. So this is a swapping. Let's look at this third one, which is minimum from. So this is the algorithm itself that compares the target against the remaining elements inside the array. And notice that the position start with the original positions at +1. So wherever the count was, starting with count equals 0, but count could be 36, 58. But your second loop or the remaining elements always starts at whatever that target count is +1. And this gives you O of n squared is y, because there are 2 loops. There's 4 loops plus the inner loops. So this is O of n, and this loop is O of n minus 1. But because they're nested, the total complexity is O of n squared minus n, which is n squared. Let's clear the screen and focus on array. And notice that the array is being passed in as the name itself. So remember from your previous lectures, the name of the array points to the memory address of the very first element of the array. This A decays into a pointer. And pointers store someone else's memory address, right? So the original array has various different address, but the address that we're interested in where A is pointing to is the very first one at index 0. This way of passing array could also be written in terms of pointer using integer star A. They are equivalent. Let's move on to the next slide. So far, we've been talking about passing array into a function by pointer. We haven't talked about the prospect of passing array into a function by reference. In fact, that could be done. And the way that we write this is this. Now, this is very, very unconventional. Let's just explain the differences between the two. The very first one, when you wrapped the name of the array with a reference in front of it and put a parentheses to it, this simply connotes to a reference to an array of size integers. Now, this is exactly what we want because we want a reference to an array. Notice that the second way of writing this, where you have integer ampersand space first. So the way that we read this is we take this together and we say that we have an array called first. There's size number of elements inside of it. Each element is of a reference integer. So this is an array of size references, which is not what you want. In fact, you don't want to write it as this because that would have led to incorrect solutions. So passing an array into a function by reference simply means that you're creating an alias of the original argument, which is the array itself. So creating a reference of the array like this means that you can do a size of that. First, it is an array of 10 elements in this case. Each element is an integer. Since each integer is of 4 bytes, and there are 10 of them, you have a total of 40 bytes. If you were to do a size of first, what should you get? Size of means the number of bytes associated with that first array. Now, we're not talking about the very first element of the array. We're talking about the entire 10 elements. So that should give you 40. Hopefully, this clarifies the differences between pass by reference versus pass by pointer as far as array is concerned when they are used as a function argument.